So in your terms, you were supposed to go through and write down your terms, okay? And if I'm not going to check them, I did the other class, but I'm not taking a grade on them. It's sure helpful to have those terms because they're definitely going to be on the test. This will probably be our last test that we're going to take. Okay? So some of you, knowing where your percentages are, we're going to do, this is probably what's going to happen over the next 2 weeks. Okay? Starting Monday. Monday, we'll probably go over what's called heats of solutions because sometimes when you dissolve a solid, it heats the solution up, makes it warmer. And sometimes when you dissolve a solid, it cools the solution. It makes it colder. So that's a property that you get when you make solutions. All right, we'll probably go over that. Maybe do some problems with that. Maybe look at Henry's Law, doing some problems with that. Nothing real difficult. Most of these are just ratio problems. X over y equals x over y, and then you just go through and cross multiply or however you want to do to solve it. Really easy setups. Okay. I would say Wednesday or Thursday to have a test. It won't be a full-fledged probably test in 100 points, but it'll be probably about 60 points, 70 points. Okay? Toward the end of that week, we're going to get into this thing called acids and bases and some definitions with that. And then we're going to introduce you to pH and pOH and acids and bases and the whole spectrum of acids and bases. Then next week, probably starting with Monday, I will show you titration and what that's all about. And then Tuesday, you can have time to practice titration. Wednesday, you're going to get your unknown. Okay, this is the week before finals. An unknown is I give you a solution and you have to titrate it to determine what the concentration is of the solution, the molarity of the acid. And you're going to get 2 of them. So you can do that, both of them Wednesday. You can do one Wednesday, one Thursday. You will get some information out for the final. I'm debating whether to give those who are proficient on the science test based upon last year's cut score. Cut score is how many you have to get right to be proficient. And if you are above that and are proficient, I'm debating whether to have you come in and take finals that are juniors. If you're sophomores, you got to take the final. But hopefully, next year as a science group, we can get together and make a decision whether you have to come in for finals or not based upon being proficient as juniors. So sophomores this year, whatever science class you take next year, maybe you don't have to come in for finals. Okay? And we'll have to discuss that because I know like Mrs. Christensen teaches physics, and that's a college level course if you want to take it as a college level course. So an anatomy and physiology is going to be, I think, a college level course so you can get credit through Peru State next year. I think they're going to try to work that in. And so there's certain requirements they have to do, and so I don't know, I would think physics, they would probably be taking their final before final week anyway, so it probably would be something you wouldn't have to come in anyway. But I'm debating whether I'm going to do that or not, so I haven't made a decision, but I'm thinking about doing it. Okay? And we should have everybody's number right out of 60. And then we can look at last year's kind of place where they cut it at, and it could change a little bit, and see if that would be the case, that you don't have to come in. Okay? So enough with that. You should have something similar to this on solubility. Solubility is the amount of solute. So that's the stuff that's being dissolved. Okay? Needed to make a saturated solution. So we get this term called saturated. It's going to come up quite a bit. Okay? The term saturated. And so we'll look at that. You should have a term with that. In a set amount of solvent. So they have to tell you how much solvent you have, because if they don't, you really can't get a solubility. Okay? It's kind of like speed. You know, meters has to have seconds to determine the speed, like meters per second, or miles have to, on a speedometer, is miles per hour. So you have to have a set amount of time, because if you say, well, I was going around 20 miles, you're going, what do you mean by 20 miles? How fast was you going? Well, about 20 miles. And they go, well, is that 20 miles per hour? What is that? Okay, and oh yeah, 20 miles. And so you have to have a certain amount of solvent. Okay, and they choose to make it 100 grams. If you look at the top of that table, the bottom of page 410, they say per 100 grams of water. Now that table would look a lot different if it was per 1,000 grams of water. Everything would be 10 times bigger. Those are maximum amounts. Those are called saturated levels. You can't hold any more than that amount of saturation. Okay? Any questions with that? We'll get to that chart here in a second. You should have terms something similar to this. They're not exactly what the book definition is, but they're really close. Saturated, the solvent is holding a maximum amount of solute. So if it's saturated, it's maxed out. Unsaturated means that the liquid that the solid's dissolved in, called the solvent, can hold more solute. So you can put more in if you wanted to. Okay, it's like a car. You start putting people in the car. Our saturated level in the van, driving up on a game, or whatever, is 11 people. We cannot have more than 11 people. Now, can you put more than 11 in there? Yes. Has it been done? Probably so. But is it legal? No, it's not legal. Okay? And so that's saturated level. It can hold 11. Our buses can hold only a maximum amount of certain people. Okay, that's it. Elevators can hold a maximum of, when you get on there, what is it, like 3,000 pounds sometimes? They say, you know? It's like, wait a second, we got way too many people in here. And I'm looking at some of the people in here, and I think we're overweight. I don't know. I'm getting off. I'm going to take the stairs. Okay? So there's a maximum amount that can hold. Can it hold more? Yes, it could, but not legally, not safely, maybe. Supersaturated is something like when you get on an elevator and you're over the threshold. I think weights of, what's the weight of semis on the roads? What can they be? You know? Anybody know? Used to be around 80,000 pounds, and if they pull in to a check station, they're over that, they get fined. Okay? So can you have more than that? Yeah. But if you pull over and they check you, then they're going to get a hefty fine with that. So supersaturated is something that can hold more than can normally hold under normal conditions. Can you do that? Sure. You can make a supersaturated solution. That's what these two are up here. So we're going to show you here in a second what a supersaturated solution would do. Okay? All right. Let's do that now. Let's go ahead and see what's going to happen. Okay, so what we're going to do, using page 410 from the book, is we're going to go ahead and do some samples of ratios. And all they are just ratios. Okay, that's all we're going to be doing. So this is the first one we're going to do. And so you have to look up KCl, and you have to look up the temperature of it at 20 degrees Celsius. When you do that, you're given information you can use to solve this problem. Okay? This is going to be a ratio problem. So when you look up KCl at 20 degrees Celsius and find its solubility, on page 410, it's 34.2. Does everybody see? At 20 degrees Celsius, it's 34.2. Okay? So 34.2 grams of KCl over 100 grams of water. That's its solubility. That's saturated. What we want to do is we want to see what we need to have to make the same saturated solution, but with more water. So 500 milliliters is the same as 500 grams because water's density is 1 gram per milliliter. That means they're the same. So over here I'm going to put, well, how much can dissolve if I've got 500 grams of water? Okay? So I want to solve for how many grams of KCl. So if I solve for this top here, then that'll tell me how many grams I would need to make a saturated solution. So I'd like somebody to calculate that and come up with an answer. Okay? These are notes for you guys to take. Whether you take them or not, that's up to you. But this is the type of problems you're going to solve probably tomorrow. If you're not here, we'll probably be solving some of these problems tomorrow in class.
Oh, are you solving them?
How much?
171.
Okay. So we can dissolve 171 grams of KCl. Any questions on that? Thank you. Anybody have questions on that? Okay. Now we're going to apply some information that we already know a little bit called saturated, unsaturated, and supersaturated. We're going to treat a problem a little bit differently now. Okay? So what we're going to do is we're going to go ahead and must be running errands today.
I am, sorry.
That's okay.
They're bringing 2 more. Maybe, hopefully
Now,
maybe tomorrow.
to clarify that, just to clarify. Okay, so then what we're going to do is we'll do a couple examples of this, and just to determine if something is saturated or not, or if it's supersaturated. So I'll show you how to do one of these. Okay, so this one is 760.9 grams of AgNO3. That would be in 250 milliliters of H2O at 40 degrees Celsius. So we're not going to write down the number in the book. We're going to use that as a comparison. What we're going to do is we're going to take the 760.9 grams of AgNO3, and we know that it's in 250 grams of water, because milliliters is the same, 1 and 1. Okay? And what we're going to do is we're going to see what actually the amount we would have in 100 grams of water. So what we're doing is we're saying, okay, we don't know if it's saturated or supersaturated, but what we're going to do is we're going to put it as if it was in 100 grams of water to see how much is actually dissolved in per 100 grams so we can compare it to the numbers in the book. So somebody go ahead and figure that one out, if you would. Again, you're not using any of the numbers out of the book other than for comparison on this type of problem.
So you just cross multiply.
Yep.
So let's say 0.9.
0.9, 760.9. Okay, so should do it real quick. What answer do you get?
304.36.
Okay, so 304.6.
36.
36.
Yeah.
Okay. Okay, look in the book. Find AgNO3 at 40 degrees Celsius. Is that particular solution saturated, unsaturated, or supersaturated? It's what? It's unsaturated. Guys, I hope you guys are paying attention. Okay? Getting a little lax back there. So, this is an unsaturated solution. Everybody see that?
Oh, wait, so you're looking at the...
So this is how much is actually dissolved in 100 grams of water.
Yeah.
When you look in the book, the value is 311. Can it hold more?
Yeah.
Yeah. Yeah.
But depend, like, it's gotta tell you what element it is though.
Yep, you have to know the temperature and you have to know the substance. Because if you don't, then you can't really make any comparison. Any questions? I'm going to have you do a couple of these examples real quick, but I need to erase one of them so that you don't have the setup for it. Okay? So I'm going to have you do two of these. When we're done, then you guys are, those that are going to be gone tomorrow, are going to take the quiz.
We'll be here, won't we?
I know that eraser gets me in trouble.
Gotta make it smaller.
I think
No,
we,
they won't.
I think we did this one.
Yeah, we did. This guy's solo
Why is everybody dressed up?
for distribution for.
Okay, go ahead and do this one. Everybody needs to do it. Some of you guys aren't doing anything today, so you got to do one thing for me at least today. And this is it. So, tell me if it's saturated, unsaturated, or supersaturated. Is take 49.5 grams of KNO3 over 150 grams, and that equals X grams over 100, right? And so what do you get for an answer? 33. Okay, 33 grams of KNO3. Now in the book, what is it?
31.
So 31.6, so that is greater than 31.6 grams in the book, so it's supersaturated. And if it would be less, then it'd be unsaturated. It'd be the same, it'd be like this stuff here. Okay? Alright, this time I need to give out the quiz. Yes?
If something's like saturated and you add crystals like that, does it have enough to form a solid? Because you put that in
It could do some forming of crystals, but it wouldn't do it to the extent of something like this. It would probably form some crystals,